Welcome back. So in the previous two videos, we had discussed about the data governance, data validation using Pyspark. Here we have discussed about the column comparisons, finding out what are the missing columns are there, as well as the schema comparison as well. And these two techniques, but there are a couple of steps to ensure the data governance. And these two are one of those things. And today we are going to discuss about the column position comparison. Column position comparison is nothing but it is not that much of necessary, but it is good to having, right? Because when you are writing here, we are writing to a Parquet file, and it is not a matter until unless we design any kind of data warehouse model at downstream side. So it's better to check always the position of the column what we are getting from the upstream side. Upstream side is nothing but source side. Of course, they will going to inform to us for us, or so and so column is going to be changed the position in a couple of days. So make sure our model is going to work fine. So we will get a prior intimation. So without prior intimation, how we can deal that one? Okay, this is just creating a scenario. Okay, it's nearly one of those real time and just creating this scenario for us. Suppose when you are writing to a delta table, okay, a table consists of let us take this one. Okay, assume this is a delta table having the 4 columns: target data frame, file path, file name, and reference data frame as well. So what happened means, when you load the next day, suppose the column position order has been changed from the source side. What will happen? Instead of the file path, which is in the second position, it is going to change to the third position. That's also like the third position. So what happened? Whatever the data inside the file path is going to under the file name, right? And whatever the data is, it is in the file name, it is going to comes under the file path. So data has been swapped from here to here, and from here to here, data has been swapped. So it is going to lead some problems. Okay, so it is completely string mean here we are taking as a string. Okay, it doesn't matter at all. Suppose we have any kind of price and quantity kind of stuff is there. Price, we will give it as a decimal or float. Quantity, most of the times we will give it as an integer. Okay, and the data type has been mismatched like that. So they may lead to some of the issues. So we need to tackle that one before going to the downstream side of our model. So it is one of the techniques we are going to implement. Okay, just to check in the column position. Okay, just give me a minute. Or else we'll create a separate notebook. Okay, don't worry. Let's create a notebook. Sorry, the YouTube page. Name it as FN column comparison position comparison. Okay, and we need to run that notebook, whatever we define. This one, setup notebook. Okay, by using the percentage run magic command. So let's call the reference data frame. So what do you mean by reference data frame? And this kind of detailing has been discussed in the previous two videos. Okay, generally we will create one table or a file, whatever, okay, which are going to reference the actual source. There we have the source file name, what would be the source file name, source column name, and their column types. Okay, it is one kind of making our model dynamic so that it can check the types and the schemas, I mean columns position and column comparison as well. And the next one is the control DF. What does it mean? Means control DF is nothing but there we are going to define the where is our path of the source file presented. Okay, right? These kind of things has been mentioned in the control data frame. Okay. So let's implement the actual code here. Column position. Let's define a function with the column position with the parameter as control df, and the spark session has been defined. Let's call it once. Whether we this is the spark session, right? Spark session has been coming from the setup notebook. Okay, already we discussed this kind of detailing stuff in the previous two videos. You can go and recheck it out once. Okay, so let's define a function column position compare. Let's give the parameters as control df. SP session is nothing but defining the spark session, and a reference data frame we will use reference df as reference data. Okay, it's better practice to keep the things in the try and catch block, except exception as p. Let's say print error processing column position. Okay, now what we are going to do means, see, we already have the reference data frame. Okay, the reference data frame we mentioned the columns in an order position. We will consider this one as a columns in the correct, I mean columns mentioned in the correct positions. So if the next time whatever the file coming from the source side, okay, has been changed, suppose order id has comes before the row id and row id is next to the order id, okay, means column position has been interchanged, right? So then it is going to throw an error. So we are assuming the reference data frame have the source columns, and whatever the values we have, those are the correct position has to be followed throughout our model development. Okay, that may be a data warehouse model, or that may be a reporting model, or that may be any kind of machine learning model as well. Okay, so we are assuming the columns, whatever mentioned in a reference data frame, is the correct way. So we are taking the columns from the reference data frame, okay, as well as from the source files, whatever the data frame we are going to develop, and we are going to compare. Comparison is nothing but we have columns, dot columns is the direct method is there, right? We are going to equal those reference df and data frames, whatever we get it from the source, and put it in an if and else logic. Okay? Before that, we need to get the data from the control data frame, right? Output validation. So if we go down, so this is our column comparison code. Okay. this is same up to here. What we are doing, we are reading the control data frame and getting the file name and file path as well. Okay. Up to here is the same concept. I am going to just copy and paste. Okay. So why I am using the map and lawyer and div and the set function is Python is the case sensitive, right? So if suddenly we have one column with this all are in a lower case, suppose let us say customer name, where customer name is completely customer name. Okay, this is completely in lower case. In the next day, what happened? Column name has been changed. I mean, just capitalized that one, customer name in the next day. So what happened? So whatever the reference column name we mentioned the reference data frame, and our model assumes like okay, there is some sort of column has been changed, and it is going to raise the missing column error. So that is not going to be happen. Why? Because values are same, data type is same. Just capital. I mean, just capitalize the couple of things. Okay, customer and the name. I mean, see, they just capitalize the C and the N. Okay, even though the values are same, data types are same, it's going to raise the error. So what I'm going to doing is make everything lower. Okay, making everything lower cases. Okay, from on both sides. Okay, at the source side and at one and at the stage side as well. Okay, and set is not about getting the distinct columns. And here again, I am converting to the list. Why? Because it's good to see whatever the column names in the list, and it is easy to compare as well. Okay, rather than putting in a dictionary or putting in set. Let's run this. Okay, fine. And the next thing what we have to do, get the column names from the reference data frame. Okay, ref filter equals reference data frame dot filter. Now, on which column we need to filter SRC file name. Okay, if the SRC file name is equal to order data, get the columns whatever presented in the with respect to the order data. Okay, that is what I am going to do here. SRC equals to okay. We have the file name variable coming from the control data frame. Okay, equals to file. Next thing what we have to do, so we will get the column values associated with the file name, and we need to make them to the lower case as well. Okay, means we need to iterate to each and everything and make the lower case. Here we can use the flat map concept as well. Either we can go with the reduce also, not an issue, but flat map suits more rather than the reduce. Reduce is mostly used for the iterating and making the aggregation stuff like or okay plus and this kind of stuff. That's why I'm choosing the flat map. Flat map is not about take the each and every value out of the list and make them lower or make them upper, whatever our requirement as per our requirement. Okay. So if you look at here, this is what we did before. Same thing only. Nothing going to be changed. Okay. And making to the list again. Bring this one as well. Reference topics. So let's define a file format, I mean formatting condition. Reference columns for file, file, file here as well, just for the sake of understanding. Okay. Now we need to implement the actual logic. What does the mean by actual logic? There is not that much of logic involved, but we need to do that. If df columns, right? If df columns equals to ref columns, now I am going to say like print column positions or same for the file and give the file name variable. Okay, I am going to say that one. And you can write to the destination, okay? Whatever the destination as per your business requirement, either it may be delta table or write into a Parquet as well. Or even it's writing to a SQL Server database table, okay? So I'm going to say writing to the destination. Suppose you want to write it to a Parquet file, you want to give the logic dfs dot write dot format Parquet and give the option as header equal to true and match schema as well, match schema as true. Okay, those are the best things we can perform. And even you can give the comparison and save the file. Okay, I will show you this way. dfs dot coalesce. Why coalesce is nothing but just coalesce is means what? Whatever the partitions present in the node, worker node, it is going to make it into a single file. Okay, while creating a Parquet file, we will get number of unwanted files. Okay, like success and some kind of stuff is there, and I don't want those kind of stuff. Okay, and I'm making to the cohesive one. Means getting all partitions into a single file instead of in multiple files. I want to make sure my destination file have all the values at one file only. Okay, all the records that may be 1,000 or 10,000 records that should be in one destination file. That would be in one Parquet file. So that's why I'm using the coalescing. Okay, even though you can use the repartition is a byte transformation. It may take some time. Okay, and you can say write format Parquet. If you are writing to delta, it is going to say the format as delta. Okay, and option made this schema, and you can call it true. Save and give your path. Okay, like this you can write the data frame to the Parquet file if it is a successful. Else columns position or not save for the file. Okay, what's the file name? Give the file name, and we want to know what are the columns. Okay, and in which order they are presented. Okay, that's right. Again, I'm going to print the here are the actual columns position df columns. Okay, that's good. Now run this code. Yes. Now call the function, whatever we define, column position compare, control df equal to control dot df, sp session equal is nothing but the spark, whatever we define in the data setup file, we want to get the one. Reference df equal to reference df, and I am running this. List cannot be initiated, use list. Think we list somewhere. Sorry, not capital L, small L, right? Run again. Run again. Okay, as you can see, column positions are same for the orders data. Data frame is on the right into the destinations as well. So like this, we can check the positions of the columns. Okay, just get the columns from the reference data frame and our actual data frame and compare them. In between, make them to the all of them into a lower case. Okay, and convert to the list. Y flat map means we need to iterate to the source columns. Okay, Y flat map, we need to iterate to each and every value in the source column and make it to the lower case. That's why I use the flat map condition. Okay, this is how we can make the column position comparison. Of course, it is not that much of necessary, but it's good to have. Okay, rather than getting the error at downstream side. Okay, we are minimizing the time and checking out at while data dumping from the stage to the raw layer. Okay, so that in this way we can do the column position comparison. So far we covered about column comparisons, means finding out the missing columns, schema comparison, okay, and column position comparison as well. In the next video we can discuss about the how we can filter out the duplicate record and write into the one of the destination, filtering the non-duplicate records and write into the another destination. Suppose you we have the gen 2. Okay, suppose we have the Azure storage or any kind of AWS is there, and you created two folders, bad records and good records. Bad records is nothing but you can send the whatever the duplicate records to the bad records folder, and the non-duplicate records to the good records folder. Okay, suppose that is the condition. So according to that condition, how we can write the logic, we can see in the next video. Also, uh, sometimes we have the YAML file. Okay, in the YAML file they will going to mention the source names. Okay, what are the targeted table should be like this control df. I mean, so far we have the control df reference df as a data frame as a file, and okay, as a csv file, and it doesn't bother us creating a data frame on top of the csv file. It doesn't bother us as much as they can. So but we will get YAML file sometimes. If there is any YAML file, how we can make use of the YAML file and getting our model to be done. Okay, those are going to be discussed in the next video.